stationary points where the curve turns, and this time we want to look at some more examples on stationary points. Example 1, find the nature of the stationary point on the curve y is equal to x3. Now, if you look at the test, I mentioned two tests, the sine test and the d2y by the x2 test. So, we want to use the sine test. We are given y is equal to x3. So, this is how you answer this question. Y is equal to x3. You differentiate dy dx will give you 3x squared. Excuse me. At the stationary point, dy dx is 0. Don't forget, at the stationary point, dy dx is equal to 0. So we equate 3x squared to 0. And we have x squared is equal to 0 and x is equal to 0. So we know x is equal to 0. So we want to find the nature. So we want to use the sine test. We are using the sine test. This is what we do. You pick your x, then you pick your dy dx. Let me say sine of dy dx. Dy dx is this one here, 3x squared here. Then we make a rough sketch to see. At the turning point, the gradient is always 0. So we have 0, even here to be 0, here to be 0. Then we pick a number which is less than 0. A number less than 0. So let's say negative 1. When you put negative 1 here, it will be negative 1 squared, which is 1 times 3. So this is positive. Give you a positive. Then we pick a number which is greater than 0 again. A number greater than 0 is 1, for example. You put 1 here, 1 squared is 1 times 3, 3. This is also positive. So now, a sketch. We said positive, it goes like this. 0 is like this. Positive again, it goes like this. So if you look at the sign here, this is a point of inflection. Therefore, we have a point of inflection. A point of inflection is either positive, 0, positive, or negative, 0, negative. So don't forget that. When you see negative, 0, positive, this is minimum. And when you see positive, 0, negative, this is maximum. So we have answered question number 1 using the sine test. Let me go over again so that you get it. Find the nature of the stationary point. We are told that we have 3 stationary points. We have maximum, minimum, and point of inflection. So how do you know that this particular curve, the turning point which is there, is maximum, minimum, or point of inflection? So this is how you go about it. You are given y is equal to x3. You differentiate. dy dx is equal to 3x squared. The 3 comes down, you subtract 1, you have this. Then, I've told you that at the stationary point, dy dx is 0. So whatever you get here, you equate to 0. Then you find the value of x. So here, we have seen that x is equal to 0. And we want to find the nature of the turning point, the nature of the stationary point. So, which of the tests do we use? We have two tests. We have the sine test and the d2y by the x2 test. So here we are using the sine test. In fact, the sine test is for simple functions like this. The d2 test is for maxima and minima. So we are using the sine test. Now look at what I've done here. I've made a small table here. The first column here, I've got x, and this x will always be there because we differentiate with respect to x. Then under x, I've got the sine of dy dx, because the sine will tell me the nature of the turning point. Then I'll make my own rough sketch. Now, after this column, then I'll pick a number which is less than 0. A number less than 0. So a number less than 0 is -1. So when I put -1 here, -1 squared, 3 -1 squared will give you a positive number. Then 0, if I put 0 here, 0 squared will give you 0. 3, 0 squared will give you 0. Then I'll pick a number greater than 0. I'll pick 1. So I have 1 squared. And it's also positive. So 1 is positive, it means the curve is going up. 0, it means it is parallel to the x-axis. Up again. So when you see positive, 0, positive, then it is a point of inflection. So that's how we answer such questions. Unfortunately, since 2016, the ECZ has only brought one question on this. So I'm hoping this year they will bring a question on that. So let's look at example 2. Find the nature of the stationary point on the curve y is equal to x4. Now, here we have y is equal to x3. This is y is equal to x4. So, this is how we answer this question. Y is equal to x4. First thing to do is to differentiate to find dy dx. So, dy dx will give you 4x3. The 4 comes down, then you subtract 1 from 4. 4x3. Then you say that at the stationary point, dy dx is 0. At the stationary point, dy dx is equal to 0. So we equate this to 0. 4x squared is equal to 0. And x is equal to 0. So now, we know s is equal to 0. So we want to use the sine test to find the nature, whether it is maximum, minimum, or a point of inflection. So we need to make a simple table. The table, you have your x, you have the sine of dy dx. What is your dy dx here? 4x squared. You pick a number less than 0. 0 and a number greater than 0. A number greater than 0. So we pick -1. When you take negative, sorry, there's a mistake here. This is 3. 4, 3. So when you pick -1 here, you have 4 -1 to the power 3. And this will give you negative. 0, when you put 0 here, you have 4, 0 to the power 3. This will give you 0. Then you pick 1. 4, 1 to the power 3. This is positive. Then you make a simple sketch to know the nature. Negative means the curve is coming down. 0 means parallel to the x-axis. Positive means it's going up. Therefore, this is a minimum turning point. A minimum turning or stationary point. Very simple. Good. So we've seen 2 examples. Let's pick one example on stationary. Then another example on coordinates, so that you have all the various examples. Example 3. The equation of a curve is y is equal to x squared minus 2x. Find the coordinates of the stationary point. There was something similar like this in 2016, which appeared. The equation of a curve is this. Find the coordinates of the stationary point. They are not asking you to find the nature, but they are saying just the coordinates, the y and the x value. If they say nature, that is where you use the sign test. So here we are just finding the coordinate of the stationary point. This is how we answer this question. We are given y is equal to x squared minus 2x. So you find dy dx. This will give you 2x minus 2. At the stationary point, dy dx is equal to 0. So at the stationary point, dy dx is equal to 0. So we equate dy dx to 0. At the stationary point, dy dx is 0. And what is our dy dx? Is 2x minus 2. 2x minus 2 is equal to 0. This is a simple equation. We take this side, so we have 2x is equal to 2 and x is equal to 1. So we have x to be equal to 1 here. Then we want to find the coordinate of the stationary point. So the stationary point occurs at where s is equal to 1. So what is the y value? When s is equal to 1, y is equal to x squared minus 2x. Y is equal to 1 squared minus 2, 1. Y is equal to 1 minus 2, and y is equal to negative 1. So the coordinates, therefore the coordinates of the stationary point is 1, negative 1. You are done. As simple as that. Let's look at another example on coordinates. The equation of a curve is y is equal to x squared minus 4x plus 5. Find the stationary point. Good. Find the stationary So this question comes in different forms. Find the nature of the turning point. Find the coordinates of the stationary point. Find the stationary point. All questions on this same topic. So here we have the equation of the curve. We are finding the stationary point. Y is equal to x squared minus 4x plus 5. dy dx is equal to 2x minus 4. At the stationary point, dy dx is equal to 0. At the stationary point, dy dx is equal to 0. At the stationary point, dy dx is equal to 0. So we have 2x minus 4 is equal to 0. 2s is equal to 4. And s is equal to 2. So the point where the stationary occurs, where the curve turns, is where s is equal to that. Therefore, the stationary point occurs where s is equal to 2. The last example, the curve y is equal to ax3 minus 12x plus 2 has a stationary point where s is equal to 2. Find the value of a. So we are given the equation of the curve, y is equal to ax3 minus 12x plus 2. Then at the stationary point, dy dx is 0. So we find dy dx. This one will give us 3ax squared minus 12. Now, the stationary point occurs where dy dx is 0. So, at the stationary point, dy dx is 0. So we have 0 is equal to 3a. X is given as 2. 2 squared minus 12. So let's simplify this. We have 0 is equal to 2 squared 4, 12a minus 12. So this comes here, 12 is equal to 12a, and a is equal to 1. So that is how we answer such questions. Read the question, understand it, and know what they are asking from you, then do exactly that. Sometimes you'll be asked to find the stationary point, or the value of a constant, or the coordinates. But always remember that the stationary point occurs where dy dx is equal to 0. Thank you very much. We have a number of applications, but for ordinary mathematics, we are just looking at these two applications. Tangents, normal, then stationary points. The rest are for pure mathematics. Thank you. The next time we meet, we'll be looking at integration. We are done with everything concerning differentiation. Thank you. There will be exercises after every lesson, and answers will be provided. So after you've gone through the work, try the exercises on your own, then you refer to the answers where